In this lesson, we are going to look at how changing a coefficient number increases or decreases the number of moles in a chemical formula by multiplying by that coefficient number. So let's review. The coefficient is the number in front of a chemical formula, right? And like in this case we have 3. It tells us how many of that substance. So how many of this substance? In this case that's 3, so that tells you there are 3 of that substance. And then we have the little number on the bottom right here. Those are subscript. It tells you how many of those specific atoms of that specific element. Now in this case, that 3 tells you there are 3 O, or 3 oxygen. But if we have a 2 outside, or a number outside a parenthesis, that tells you there are 2 of what's inside a parenthesis. So let's go back to this. We need to realize that different substance is represented by a specific chemical formula. Okay, so what does that mean? Well, that tells you that each substance, which the word substance means is pure, like water, right? Let's look at water, H2O. H2O will always represent water, the water that we drink. And it has a fixed ratio of different elements. That is 2 hydrogen. So we have 2 hydrogen to 1 oxygen, and that ratio will always stay the same. Now, what happened when we change the subscript? If I were to change this into H2O2, is this still the same substance as water? No. So that tells you that this has become a new substance. That is because the ratio is no longer the same. And of course this is the basic of this. There's also other exceptions too. And that tells you that you cannot change the subscript just because we want to add more moles of oxygen or make it lower because we want to remove the number of moles of oxygen. So in this case we are going to look at how can we change the values of number of moles of different atoms in a substance, but still keeping the substance the same substance. And the only way you can do that is you have to change the coefficient. So you can only change the coefficient. When you change the coefficient, you increase how many substance, or you decrease how many substance, but the substance is still the same. So let's look at this chemical formula. And in this case, the coefficient is 4. That tells you there are 4 calcium, 4 carbon, and 4 of 3 of O, 3 right there. So give us a total of 12 oxygen, right? Now the task is this. How can we change this right here? How can we change the coefficient to give us the specific number of moles of different element? So change the given chemical formula above, which is this right here. We don't really care about that right there for now, okay? So that it will contain 3 moles of carbon. So what would the coefficient be if we want 3 moles of carbon? Right there, the subscript is 1 because there's nothing there. So to do that, to give us 3 moles of carbon, that right there must be 3. So we have 3 CaCO3. But by changing the coefficient, we change the number of the substance, right? That's going to change the total number of moles as well. So we need to recount. In this case, how many calcium do we have? We have 1 right there, but there are 3 of it, so that gives us 3. And for carbon, okay, no subscript, just 1, but there are 3 other substance, so that gives us 3 again. And for oxygen, okay, we have 3 because of that subscript 3 right there, multiplied by 3 because we have 3 other substance, that gives us 9. So what's the total? 3, 6, 9. That gives us a total of 15 mole. Now do you see how changing the coefficient will change everything in terms of the number of moles? Let's try another problem. Change the given chemical formula above. Change this again. Okay, so that we will contain 9 moles of oxygen. And if we look at this right here, right, that 3 right there tells us there are 3 of oxygen. So how many of the 3 oxygen do we need to give us 9? And of course, that would be 3. Oh, there's 3 again. So 3 CaCO3. That 3 right there multiplied by that 3 gave us 9 moles of oxygen. And of course, because the coefficient stayed the same, the total number of moles for the new coefficient would be 15 as well. So isn't that easy? Let's try another problem. Here we have calcium hydroxide, okay? So change the given chemical formula above so that it will contain 3 moles of calcium. So notice how calcium right there, right? The subscript is 1. So we need 3 of that. We had to put a 3 there. So our answer is going to be 3, CaOH2. Okay? Now how is that going to change our total number of moles? Of course, for calcium, we have 1, but there are 3 of the substance, so that gives us 3. And for oxygen, see how we have that 2 right there, that tell you there are 2 of this. So of course, for oxygen, it will have 2, but 3 of 2, that give us 6. And then for the hydrogen, same thing, we have 2 of the hydrogen because of that subscript right there, but we have 3 of it. So 2 times 3 give us 6. And what is the total number of mole? 3, 6 is 9, plus 6 again, that is the total of 15 moles. Isn't that easy? Now let's try another problem. Change the given chemical formula above, which is the same one, so that it will contain 4 moles of hydrogen. Now we focus on the hydrogen, right? Then determine the total number of moles from the new coefficient. So I want 4 moles of hydrogen, which right here, each one give me 2. So how many more? So each substance right here give me 2. So how many more do I need? Of course, I need 2. So therefore, we have 2 CaOH2. Okay? And that will give us, for the hydrogen, notice how we have 2 right there. There's 2, but we have 2 of the substance. That give us a total of 4 hydrogen. And how is that going to affect our total number of moles? Well, of course, for calcium, it's just 1. So 1 times 2 give us 2. And for oxygen, is 2 right there, right? And time the number of substance give us 4. So in this case, we have 4 to the 6 plus 4. That gives us a total of 10. Isn't that easy? Now let's try another problem. Here we have this chemical formula, again with the coefficient, but we can ignore that now, okay? So change the given chemical formula above so that it will contain 18 moles of hydrogen. Then determine the total number of moles from the new coefficient. So again, we can ignore that. We know that 1 water molecule has 2, okay? But I want 18 of it. So you can ask yourself, everything is mathematical. We would have 18 2 times x, which is the number of substance that we have, right? You want to think this in mathematical term. So 2 times what will give us 18? Of course, x would be 9. And if we think in a logical term, if each water give me 2, how many water molecules do I need to give myself a total of 18? Of course, 9. So the coefficient would be 9H2O, okay? Now, let's go back to our hydrogen. Of course, 2 times 9 give us 18, and for oxygen, 1 right there. So 1 times 9 give us 9. So give us a total of what? 27 moles total. Isn't that easy? Now let's try another problem. Change the given chemical formula above so that it will contain 12 moles of oxygen. Oh, isn't that easy? Since each one of, let me write this down here. Since 1 water molecule has 1 oxygen, how many water molecules do I need, or how many moles of water molecules do I need to have to give myself 12 moles of oxygen? Of course, that would be 12. So your oxygen, 1 times 12, give you 12. And for hydrogen, there are 2 of it. So 2 times 12 give us a total of 24. And what's the total number of moles? Of course, that would be 36 moles total. Isn't that easy? Are you ready to try some more complicated problems? Are you ready to try some more challenging problem? Here we have this chemical formula, right, with the coefficient, but truly this is a chemical formula that represents the substance. So change the given chemical formula above so that it will contain 4 moles of nitrogen. So we focus on the nitrogen, okay? Then determine the total number of moles from the new coefficient. Notice how that subscript outside the parentheses right there, right? That tells you there are 2 of nitrogen. So each one of the substance give you 2 nitrogen. And how would I get 4 nitrogen total? So of course I need another substance, right? Because each only give me 2, and then I have 2 of it, that give me a total of 4. So that tells you the coefficient must be 2. So we have 2Ca, NO3, 2. And we look at the nitrogen, of course. There's 2 for each nitrogen, and times the 2 of the substance, that give us 4. And for calcium, it's just going to be 1 times 2, give us 2. And then for the oxygen, we have 2 of O3, so that tells you that each of them has 6 oxygen, but now we have 2 of the substance, that gives us 2, so that is 12, and then we add them all together, 6 plus 12, that gives us the total of 18 mole. Isn't that easy? Now let's try another problem. Change the chemical formula above so that it will contain 12 moles of oxygen. Now, of course, I'm looking for the oxygen, right? So let me rewrite this again. CaNO3, 2. So each of them, or each of this substance has 2 of O3. So that equal to 6, isn't it? So we have 2 O3, so each one is 6. But I want 12, so how many more of this substance do I need? Of course, it's 2. So multiply by 2 right there. That's how I get that number. That gives us 12 moles of oxygen. Now, the calcium, of course, is going to be 2. And then what about for the nitrogen? Let me write down the nitrogen. So there's 2 nitrogen, and 2 of that 2 give us a total of 4. So 12, 2, that's 14 plus 4. That gives us a total of 18. Isn't that easy? Oh, the same answer as that one. Huh. Now look at this chemical formula. It doesn't look complicated. It does look complicated, okay? So, but it's actually pretty easy. Change the given chemical formula above so that it will contain 18 moles of carbon. And of course, determine the new totals of moles. So we have, this is the substance, isn't it? C6H12O6. And I want 18 moles of carbon. Here's carbon. Each of them has 6. So how many more do I need? If I want 18, 6 times X, okay, what is that X going to be? Of course, X is going to be 3. So, right there, that's how you think mathematically, okay? Or you can say, I have 6 for each one of them. How many more do I need? I need 3 total. That gives us 6 times 3 equal to 18. So, of course, carbon is 6 times 3 equal to 18. And hydrogen is 12 times 3 because of 12 right there. And that gives us 36. And if oxygen, 6 times 3 gives us 18 again. Oh, here we have, what's the total? Well, 18 plus 18, that's 36. Plus another 36. So that gives us 72 mole total. Let's try another one. How about that? Here I want the new coefficient that gives us 24 moles of hydrogen. So rewrite again. C6H12O6. Notice how I ignore the number 3, right? I restart from the chemical formula itself. So here I want 24. If each one give me 12, how many more do I need? Of course I need another one. So of course this is going to be 2. So for H would be 12 times 2 give us 24. For C would be 6 times 2 give us 12. And for O would be 6 times 2 give us 12 again. So 24 plus 24 give us a total of 48. Isn't that easy? And that is how you change the coefficient to get. Remember, you can only change the coefficient, nothing else.